Welcome to today's paper reading. Today's paper is titled, Storymaker, Towards Holistic Consistent Characters in Text-to-Image Generation. This technical report was published by Jingguang Zhou and colleagues from Xiaohongshu Inc. Storymaker is a personalization solution designed to generate images that not only maintain facial consistency but also ensure consistency in clothing, hairstyles, and body features. This allows for the creation of a cohesive narrative through a series of images. The system integrates facial identity information with cropped character images, including clothing, hairstyles, and bodies, using the Positional-Aware Perceiver Resampler (PPR) to obtain distinct character features. To prevent the intermingling of multiple characters in the background, Storymaker separately constrains the cross-attention impact regions of different characters and the background using mean squared error (MSE) loss with segmentation masks. Figure 1 showcases the capabilities of Storymaker in generating consistent and coherent character images across different narratives. The first 3 rows illustrate a story about an office worker's day, demonstrating the model's ability to maintain character consistency while varying scenes and actions. The last 2 rows depict a story inspired by the movie Before Sunrise, highlighting the model's versatility in handling different character interactions and settings. This visualization underscores Storymaker's effectiveness in creating holistic, consistent characters in text-to-image generation. Storymaker is a novel approach in text-to-image generation that focuses on maintaining holistic consistency. It not only preserves facial identities but also ensures consistent clothing, hairstyles, and bodies across generated images. This is achieved by conditioning the generation on face identities and cropped character images, which include clothing, hairstyles, and bodies. The Positional-Aware Perceiver Resampler (PPR) is used to integrate this information, deriving character features that are crucial for maintaining consistency. Additionally, Storymaker allows for variations in backgrounds, character poses, and styles through text prompts, enabling the creation of a series of images that tell a coherent story. This approach also facilitates applications such as clothing swapping and image variation, and is compatible with plugins like LoRa for stylization. By regularizing the cross-attention impact region and using a learnable background embedding, Storymaker ensures that different characters in the background do not interleave, enhancing the quality and fidelity of the generated images. In the domain of subject-driven text-to-image generation, early approaches required test-time fine-tuning of specific text tokens, which was time-consuming due to the slow optimization process. Recent methods have eliminated the need for fine-tuning by integrating additional modules while keeping the primary pre-trained models frozen. Identity-preserving human image generation is a prominent area, with solutions like Face Studio and IP Adapter Face ID using ID embeddings to maintain facial fidelity. The Stable Diffusion model operates within a low-dimensional latent space to improve computational efficiency. It uses a variational autoencoder, V, to compress input images into a latent space and a UNet for the denoising process. The IP adapter introduces an image prompt adapter that allows the model to generate images based on an image prompt, using an image encoder and a decoupled cross-attention mechanism. The training objective for Stable Diffusion is to minimize the denoising error, which is conditioned on text embeddings and involves an iterative denoising process. Figure 2 illustrates the architecture of our proposed Storymaker model. The facial image and character image are first embedded using the face encoder and image encoder, respectively. These embeddings are then refined through our proposed Positional-Aware Perceiver Resampler (PPR) module. To inject these refined embeddings into the diffusion model, decoupled cross-attention with LoRaS is employed. At the bottom of the figure, the attention loss on cross-attention maps with the segmentation mask is illustrated. The core of the PPR module is also depicted on the right, showcasing its role in refining the character features and facial identities. This architecture ensures that the generated images maintain not only facial consistency but also consistency in clothing, hairstyles, and bodies, facilitating the creation of a coherent narrative through a series of images. The Storymaker method begins with the extraction of reference information. This involves using ArcFace for face detection and the Clip Vision encoder to maintain consistency in facial features, hairstyles, clothing, and bodies. The extracted information is then refined using the positional-aware perceiver resampler, which transforms the facial and character features and introduces a learnable background embedding to distinguish different characters. To ensure pose diversity, the training is conditioned on poses using Pose ControlNet, allowing for the control of character poses either through text prompts or by guiding generation with new poses during inference. The experiments conducted by the authors involve a comprehensive dataset of 500,000 images, which includes 300,000 single-character images and 200,000 two-character images. The training of the model is based on Stable Diffusion XL, with a training process spanning 8,000 steps distributed across 8 NVIDIA A100 GPUs, each with a batch size of 8. For evaluation, the authors use metrics such as clip image similarity, clip I, face similarity, face sim, and clip text similarity, clip T, employing the Buffalo_L model for face detection. The evaluation dataset consists of 40 characters and 20 unique text prompts, generating 4 images per prompt. Table 1 presents a quantitative comparison of character condition generation methods. The best results are highlighted in bold. The table shows that Instant ID achieves the highest face similarity, face sim, percentage, indicating superior identity preservation. Storymaker, on the other hand, attains the highest clip I score, reflecting the consistency of the entire portrait, including face, hairstyle, and clothing. Photomaker V2 leads in clip T, suggesting better adherence to text prompts. These metrics provide a comprehensive view of the performance of various models in character-conditioned image generation. Figure 3 presents a visual comparison of single-character condition generation methods. Storymaker, compared to IP Adapter Face ID, Instant ID, Indepth, and Photomaker V2, excels in maintaining both face fidelity and clothing consistency. While IP Adapter Face ID performs well in clothing consistency, it struggles with adhering to text prompts and maintaining face fidelity. Instant ID, on the other hand, demonstrates superior face similarity, attributed to its extensive training data and the IdentityNet controlling module. Figure 4 showcases the capabilities of Storymaker in generating images of 2 characters. The first 2 columns present different reference character images. The middle 4 columns highlight Storymaker's realistic synthesis, maintaining consistency across faces, clothing, and hairstyles. The last 4 columns show stylized synthesis results, where the character embedding is set to 0, demonstrating the flexibility and versatility of the model. Figure 5 showcases the diverse applications of Storymaker in text-to-image generation. It highlights the ability to transform characters while maintaining clothing consistency, as seen in Figure 5a. Additionally, Storymaker demonstrates clothing swapping capabilities, achieved by replacing the character image with a clothing image, indicating that the character embedding contains clothing information, as shown in Figure 5b. Furthermore, Storymaker integrates seamlessly with LoRa and ControlNet to generate diverse images while maintaining character consistency, as illustrated in Figure 5c. These applications underscore Storymaker's versatility and effectiveness in personalized image generation. Storymaker is a novel approach for personalized image generation that excels in maintaining consistency across facial identities, clothing, hairstyles, and bodies. It enhances narrative creation by allowing variations in background, pose, and style through text prompts. The method uses the positional-aware perceiver resampler to obtain distinct character embeddings and employs MSE loss with segmentation masks to prevent intermingling of characters and background. Additionally, ControlNet is used for pose decoupling, and LoRa for fidelity enhancements. Storymaker consistently generates high-quality images and has demonstrated superior performance in maintaining character identity and consistency, especially in multi-character scenarios. It outperforms existing tuning-free models and has versatile applications such as clothing swapping and character interpolation. The model opens possibilities for wide applications in digital storytelling, comics, and beyond. In the current state of character generation, several limitations have been identified. Firstly, the posture of generated characters often exhibits anomalies and lacks harmony due to the absence of an explicit pose guide. Secondly, generating 3 or more characters simultaneously presents significant challenges, with fidelity and detail issues persisting. Lastly, the fidelity and detail of the generated clothing remain unsatisfactory, indicating a need for improvement in this area. Thank you for watching.